Hello and howdy, ladies and gentlemen. Welcome back. We're looking at the 2015 Manitoba Math Contest. So this is a written contest aimed at the grade 12 level, and we are on question 8. The lines y equals negative 2x plus 12, x equals 2, and y equals mx, so right away I can tell this is going to go through the origin, intersect to form a triangle with area 2. Find all possible values for m. Ooh. Okay, so we're going to get out our axes, and we can draw at least 2 of these. Now, depending on whether or not m is positive or negative, this thing will pass through the origin down and to the right, or up and to the right. But we do have x is equal to 2, which I guess I'll put over there. And we actually know, because the one thing had a 12 in it, didn't it? Want things to be slightly proportional. So maybe we'll make, first of all, we'll get some colored lines out. So we'll call this x equals 2. And our other line is negative 2x plus 12. So let's say 12 is up here. Negative 2x, so it's pretty steep. And I can actually figure out this intersection point. X equals 2, so negative 2 times 2 is negative 4, so this is actually going to be 2, 8, which I guess it doesn't look exactly like that, but there it is. So that's that intersection. And then we have, so either we have something like this, it goes across like that, and so we're concerned with this triangle, and so this would be y equals mx. But here we have m sort of being positive. And then we might have something else, something quite steep. I think even that's not quite going to work. But then we'd have a slightly bigger triangle like this. Regardless, we still need to work out these intersection points. So this would be y equals mx, where m is less than 0. So I'm expecting 2 possible values for m. I could be wrong, but this is what I'm expecting. I suppose we could also have one going up like this, with this one right here, and maybe an even, you can't have an even steeper one come across this side. So I'm thinking just rudimentarily, at a glance, with a very rudimentary glance and a rudimentary picture, that we might have 3 solutions for m. That's what I'm thinking right now. So what are these intersection points? Well, the intersection point of intersection of y equals mx and x equals 2 is, you guessed it, it's got to be x is 2, and then y will just be 2 times m. Okay, that one is not particularly interesting. But it does, the fact that we've got this nice horizontal line means that we can get heights here very quickly. So the heights are going to be, so consider 2, 2m to 2, 8, the base of the triangle. Our base is going to be equal to, because we don't know exactly where the intersection is, but because it could be above 8, it could be below 8, we have no idea. It could be vastly below 8, but it's going to have a length of 8 minus 2m absolute value. Okay. So there's that. And then, what's the other one we could have? Oh, I guess actually we could have one coming across like this and then having a triangle. So yeah, 4 solutions seems a bit more reasonable. So there's one base. Well, that's all the bases. It just depends on our m value. So we'll make a little note of that. Base is 8 minus 2m if m is less than 4. And base is 2m minus 8 if m is greater than 4. And you won't have m equal to 4 because that'd be a zero base, and that'd be ridiculous. Now our height is the distance from the point of intersection of y equals mx to the point of intersection of y equals mx and our other line, y equals negative 2x plus 12, the distance to the line x equals 2. But this will just be the x-coordinate of the point of intersection minus 2 and then absolute value. So what is the point of intersection of these two? Well, y is mx, so we'll have mx is negative x plus 12. M plus 2x is 12. So x is going to be 12 over m plus 2. So our height, once again, we have absolute values. We don't know which one's bigger, but we're going to say 12 over m plus 2 minus 2. And again, depending on what m is, we'll get different values. So now we have our height is 12 over m plus 2 minus 2. If m plus 2 is less than 6, so if m is less than 4, interesting. And it will be 12 over m plus 2 minus 2. Sorry, it would be the reverse of this. If 12 over m plus 2 is less than 2, this will be the distance, because it'll be a positive value. And that happens when m plus 2 is greater than 6, or rather when m is greater than 4. And you might want to show your work on that, but I think we're fine. And just remember what was our base? It was 8 minus 2m if m is less than 4. So I was expecting different m values, and we'd have interesting overlaps, but that's okay. 2m minus 8 if m is greater than 4. Okay, now it's a shame we don't have overlaps, because that makes me think that we're only going to have two triangles with a particular area. Oh well, that's quite alright. But I was really expecting more. Okay, so we want 2 to be the area, if I recall correctly. Area of 2. So that's going to be 1/2 base times height. So we want 4 to be equal to base times height. If m is greater than 4, we'll want 4 is equal to 2 minus... So if m is greater than 4, we'll have 2m minus 8 times 2 minus 12 over m plus 2 is equal to 4. I don't know, multiply by m plus 2 on both sides. Just to get rid of this, so 2m plus 2 minus 12. So we'll have 4m plus 8 is 2m minus 8. 2m plus 4 minus 12, so that'd be, again, 2m minus 8. Interesting. Okay. Did I do all that right? Yes, it looks like I did. Okay, so 2m minus 8 squared is 4m plus 8. Well, we can solve that. It's just a quadratic. So we'll have 4m plus 8 is 2m minus 8, so that's 4m squared, minus 2 times 16, so 32m plus 64. And that, well, we can divide by 4 on both sides, so m plus 2 is m squared minus 8m plus 16. And 0 is m squared minus 9m plus 14. And so we're going to have m can be, so we'll have m minus 2 and m minus 7. But an m being equal to 2 is too small. So m could be 2, m could be 7. But remember, we said m is greater than 4. So m is equal to 7. Right? What happens if m is equal to 2? No, that should still be... m equal 2 should still be fine. Because these values would be negative, but both of them would cancel each other out. I'm going to come back to that, because I think m equal 2 should be okay. Because everything should technically be positive. Okay, and what's our other possibility? If m is less than 4, then we'll have 4 is equal to 8 minus 2m. See, it's the exact same expression, just with negative signs, so it should solve the same way. So 12 over m plus 2 minus 2, so divide by 4 on both sides, so we'll get, and multiply by m plus 2, so we'll get m plus 2 is equal to 4 minus m, 6 minus m plus 2, 4 minus m, 4 minus m, and yeah, we're going to get the exact same expression. M squared minus 9m plus 14. Okay, because this line is the same thing as this line. So m is 2, m is 7. Really, because I mean, there are 4 triangles here that you can make, and if for any given y equals mx, we do have 4 triangles. Well, no, I guess not. So I guess none of these negative triangles will work out. They'll all have too great an area. Just these tiny little baby triangles in here. So y equals 7x would be 2 and 14, and so that'd be a base of 6. And then y equals 7x intersecting y equals negative 2x plus 12. It would be x is 12 over m plus 2, so 12 over 9, so it'd be 4/3. 4/3 minus 2, 2/3 is the distance. 2/3 times 6 is 12 over 3, which is 4. Divide that in half because you get a triangle. Okay, it works out. And I assume the same thing works with 2. So there you go. I was really expecting more answers there, but what can you do? So m is 2 or 7. Don't have to worry about that stuff. M is 2 or 7. That is what we wanted, right? Find all possible values of m. Yep, 2 or 7. There you go. So that's question 8 done with. On to question 9.